All right, we're going to continue learning about proportional relationships, and we're going to be able to identify them in graphs, equations, and tables. You learned about this yesterday, that the two quantities are directly proportional if they have a constant ratio y over x. The change in one variable is accompanied by change in the other, and this constant ratio is called the constant of proportionality. The constant of proportionality can never be zero. We also know this to be the unit rate. So, if the ratio is not constant, the two quantities are not proportional. And we're going to look at tables, graphs, and equations in ordered pairs to determine if the relationship between the variables is proportional. In equations, so you should be able to write equations to describe the relationship. If the situation is proportional, you will use your constant of proportionality in your equation, and you'll define your variables. So remember, this equation is going to take the form of y is equal to ax. So the y will be the dependent variable, x will be the independent variable, and a is that constant of proportionality. Again, this is how we're looking at that ratio, because if you solve both sides for a by dividing by x, you get the ratio y to x is equal to this constant rate. So this is the relationships we'll be looking at again today. In order to tell from a table if there is a proportional relationship between variables, you should check to see that the ratio is the same for all values. Now, we did this yesterday, so this was the first thing we started doing. So the ratio y to x is also known as a scale factor. You reduce or divide to find the constant of proportionality, which is also known as the unit rate, that defines the relationship between the variables. So looking at these tables, we're going to decide if it's a proportional relationship. So again, write the ratio of y to x. We see here that we have 3 over 1, and if we divide, we get a constant of 3. If we take y to x in this case, the same constant, y to x in this case. At this point, you may be thinking that you have found a proportional relationship, and then this happens, and it's approximately 2.57. Is it 3? No. So is this proportional? No. And there's no ratio equation or constant of proportionality that we can fit to this situation. It's kind of random. Looking at the next one, the y to x ratio, you can divide and get a decimal. It's okay. $1.50 over 6. Same decimal. 2 over 8 reduces down to 1/4 as well. And 250 over 10 is also the same one. So is it a proportional relationship? Yes. That ratio of y to x is basically 1/4. Your equation will be y is equal to this constant of proportionality times x. If you prefer, you could do y is equal to 1/4 of x. I will accept either. That constant of proportionality then is the decimal 25/100ths, or it's the fraction 1/4. They have the same value, so you only need to use one of them in your equation and determining the constant of proportionality, and we'll acknowledge the equality. Okay. The graph of a proportional relationship will always be a straight line and always pass through the origin. And we're going to always write the constant ratio in the form of y to x. So determine if the graph represents a proportional relationship. In the first one, it's a straight line, and I also see that it passes right here through the origin at 0.0, so I would say yes. The second one is a straight line, but it completely misses going through the origin. Therefore, I would say it's not a proportional relationship. And the reason why, in the first one we said yes and it goes through the origin. The second one we said no because it does not go through the origin. How about looking at ordered pairs? In order to tell if a set of ordered pairs is proportional, look at the ratio of y to x. Again, your ordered pairs are set up in such a way of x, comma, y. Therefore, we could put them in the correct form to find the constant. So we could take y over x, y over x, y over x, and y over x. And if you can tell, they all are equal to 1/2. Okay, so are they proportional? Yes. What is the ratio? 1 to 2. What is the equation? Again, half of x or y is equal to 0.5x, depending on if you like the decimals or not. So the constant is 1/2 or 0.5. Determine if the following equations will show a proportional relationship. So if you're given an equation, you can tell if it will go through the origin because it will be through 0, 0. So to do this, you would substitute in a 0 for the x. You will do the math. And since we get y is equal to -1 and not 0, this is not proportional. Here, when we substitute in the 0, we get y is equal to 0. And so therefore, you have the ordered pair 0, 0, which means this would go through the origin, and it is a proportional relationship. Okay, at HMS there is an average of 26 students per teacher. Complete the table to show the proportional relationship, and we're going to take it a step further and actually write the equation. So, since this is our x value, this is our y value, we're telling what our variables are. Remember, the y is dependent, it depends on x, and as the number of teachers change, so do the number of students in the classroom at a rate of 1 teacher to 26 students. So if there are 5 teachers, we could take 26 times 5, and we would get 130, right? If there are 10 teachers, it would be 260, and if there are 25 teachers, it is 650. So our y to x is 26 over 1. Our equation is then 26x. So no matter what changed in x, all we had to do was take that number times 26, that constant of proportionality, to get the new answer. Your dad's making trail mix. Determine if the quantities of nuts and fruits are proportional to each serving size shown in the table. Complete the table, write the equation, and we'll be using our constant of proportionality to do so. So we want to go ahead and write these ratios. We have y, the cups of fruit, over x, the cups of nuts. That is a rate of 4, unit rate of 4 to 1. 12 to 3 is equal to 4. 18 to 4.5 is also equal to 4, and 24 to 6 is equal to 4. So this unit rate, this is our constant of proportionality. So we have y is equal to 4x for our equation.